All right. So in our previous session, I have discussed about initial configuration of router, like how to configure a brand new router for first time, like what are the things we required, like a console cable, emulation softwares. Using these softwares, we can access the router console port. Through console port, we can configure uh, basic configuration part like setting a host name, assigning IP address to LAN interface, activating LAN interface, and setting passwords to all console port, right? And enabling telnet functionality, enable password, enable secret, like this. And Cisco IOS modes, like a user mode, privilege mode, global config. Under global config mode, we have a different sub modes like interface, line mode, and router mode. These are all the modes we have seen. And a practical I have shown you very clearly. And I given the task for to configure on 3 routers. I hope everyone you have done your practices. If you're not done, so try to do at least today. And today our topic is how to connect to different sites. So example, Lahore branch 1 in one location, which is in Chennai. Branch office 2 in Bangalore. Two different sites. How to connect it? So why they need to connect? They need a network access. All branch office 1 LAN users should communicate with branch office 2. Our ultimate target is LAN to LAN communication. Correct? So they need a network access. Even if you want to download some packet tracer software in internet, you need an internet connection. Like you want a global communication, you need internet connection. So we need a network access actually to communicate with globally or site to site anyhow. We need network access. That network access are two types between one site to another site. If you need a network access, this network access are two types of network access. One is internet access. Using a internet, like all branch 1 and branch 2 can communicate. And one more is enterprise access. So enterprise access, only branch 1, branch 2 can communicate. No other sites, no other branches. A separate network, almost like a private network. So there are two types of network access. There's two access. Two network access comes under a technology called WAN technologies. In WAN technologies, types of network access is enterprise access, like a government sectors, private sectors, like IT companies we use this enterprise access. Internet access, general public will use internet access, what we are using right now actually. In each technology have different type of technologies. Enterprise, dedicated, switched, VPN, laser line, circuit switch, ISDN, PSDN lines, frame relay, MPLS, an internet dedicated switched network broadband, laser line, PSDN, ISDN, DSL cable. These all are different type of technologies we have in enterprises and internet. Like PSDN, ISDN, frame relay, these all are outdated technologies. So we are not making use anymore actually. So in modern network, what type of technologies we are using? Currently we are using laser line, VPN, and MPLS. These three technologies. In CCNA level, we are going to discuss about laser lines and VPN. MPLS will discuss in CCNP level. So today we'll discuss about laser line. In Cisco security sessions, we'll discuss about VPN also. In internet, we know broadband like DSL cable wire. These all are different type of technologies. So let me explain about what is the difference between broadband and laser line. So point number 1, quote, WAN technology. Consider this is your network. It's all your devices. You need internet. If you need internet, we contact a service provider. And where your network, say example, my network is in location is HYD, area AMPT, road number 5, and so on building, and 5th floor or 2nd floor, I need internet connection. And where ISPs will be available, ISPs in different location. Let's say ISP is in Banjara Hills. You're asking internet connection for Amirpet. Now ISP will directly give the cable to your customer from Banjara Hills to customer location.
No.
Is it? No. So in Hyderabad Amirpet area, I'm not only the customer. There are many customers will be there, right? So in road number 5, many customers will be there. Then what ISP will do in nearby road number 5, they is to install one device called switch, like a junction box. It's like a similar to switch actually. From this device, they'll distribute to customers like C1, customer 1, and I'm a C2, customer 2, C3, customer 3. Number of customers they distribute from this ISP switch, right? From ISP switch, they used to maintain optical fiber cable. OFC. And customers, they install like internally local switch and they can connect like this. Says a broadband connection. If it is a broadband connection, for customer 2, I mean customer 2, for customer 2 ISP is telling is customer 2, you will get 16 Mbps plan. All of you, do you have internet access at your homes?
Yes.
Yes. What's the bandwidth? What's the plan? Internet speed?
100 Mbps.
100 Mbps. Okay. 40 Mbps, Nagaraj. Okay, 100 Mbps. It means, do we get always 100 Mbps?
It's a
No.
shared bandwidth.
No, it's a shared, right?
Yeah.
Yeah, up to 100 Mbps. So sometimes you can get 80 Mbps, sometimes you can get 60 Mbps, sometimes you can get 100 Mbps. So first thing is, in broadband, there is no fixed bandwidth. It's a shared bandwidth actually. No fixed bandwidth. This is point number 1. And point number 2, where customer 1 connected, customer 1 is getting internet cable from where? Customer 1 is getting internet cable from which device?
ISP,
ISP switch.
ISP
Customer 2,
Same.
same switch.
customer 3, all customers will get the cable from the same switch, right?
Yeah.
Means customer 1 traffic is going via ISP switch, customer 2 traffic is moving ISP switch, customer 3. Like all customers traffic will go via this device only. Now, what customer 3 can do is by using some high-end applications, some tools. So there is a chances for customer 3 can be monitor customer 1 traffic and customer 2 traffic. Is also part of the same device. No, you can able to capture the traffic by using some high-end tools. Is there is a possibility? Is there, right? Yes or no? Yeah. So less network security. the chances for other customers can be monitor your traffic actually. And one more point is, like there is optical fiber cable is down, failed at your area. You're not getting internet access. It's been 2 hours, 3 hours, 4 hours. And you make a call to service provider. And what service provider will reply? So there is internet cable, like a optical fiber cable is down at area. My team is working on it. It may take 4 hours or 5 hours more. Have waited 4 hours more, again another 4 hours, but still you are not getting internet. Again you call back to ISP. So ISP will still my team is working on the same. So you may get, it may take 24 hours or 1 day or 2 days. Now what we can do? Can we demand to service provider, no, I need internet connection immediately? Can you demand to ISP? No, we can't do that actually. So means there is chances for more downtime. But point is, we will get internet connection for very less price. Agree? Like 1000 rupees will get 100 Mbps like this. Very less price. You get broadband. So this is how generally broadband works. If my internet purpose is home network purpose, a small office purpose, then you can go with the broadband, no problem. But point is, my purpose is, it's a commercial network, it's a corporate network, it's a government network. Then do you recommend to use this type of connections, broadband? If it is a broadband, no fixed bandwidth. This is a corporate network. There are very software team is working on here. So software engineers are working here. They used to run some programming. They used to run some automation. So that program will be run properly. That always should be a good bandwidth actually. So bandwidth should be consistent. But here sometimes 60 Mbps, sometimes 80 Mbps, sometimes 100 Mbps. It should not be like that now. So then we'll ask for service provider. Okay, so broadband, this type of connection I'll use for my homes, but I need a office purpose. I need a dedicated a fixed bandwidth. Then ISP will provide another type of connectivity, which is a separate link from ISP to customer directly. Not with this ISP switch. There is a separate, a direct link from customer to ISP. A dedicated link. And this link, if it is a 10 Mbps plan, then you are taking a line for lease. That's lease line, or you can call fixed lines. Lease line is your bandwidth is fixed. Anytime, always will get 10 Mbps. If it's 90 Mbps, always will get 90 Mbps actually. So first thing is what? Fixed bandwidth. And is there any chances for customer 1 or customer 3 can monitor customer 2 traffic right now? No, because customer 2 is not a part of ISP switch. We have a dedicated separate link. So there is no chances other customers traffic is involved. Only customer 2 traffic will move to ISP. So almost we have a private link actually, right? A separate link. So more secure. More secure. And there is one agreement between the ISP and customer 2. If you take a lease line, ISP will give agreement actually. ISP will promising you that there is less than 1% downtime. So that agreement we called LSA, service level SLA, sorry, SLA, service level agreement. So what is in agreement? Bandwidth is fixed. You will get always 10 Mbps. And I'm promising is that there is no tampering, like other customers will not involve in your link. Only your traffic will be moved. And one more promise is that what? Less than 1% downtime, because for laser lines, there is one separate active team will be work for laser lines will with high priority. If link is optical fiber is down, it is cable is problem. So at any time, at any climate, at any moment, like the time team will come and will work action and make it ease up. There will be very high priority. Less than 1% downtime means what? Almost no downtime. So, but very high price. No, your lease line bill will be lakhs of rupees for monthly. So this is a major difference between lease line and broadband. This type of technologies we have, lease line and broadband technologies. So for corporate networks, for IT companies, so which type of connectivity, which type of technology do you recommend to use? Lease line or broadband?
Lease line.
Lease line. Yeah. So we are using currently is a lease line for corporate networks. It's clear, everyone?
Yes.
Yeah.
Point number 2. WAN topologies. Technology is okay, like laser line and broadband. Then how to design topology? So this is your head office. You need to connect it to multiple sites, multiple branches, branch 1, branch 2, branch 3. It's not a home network actually, it is head office, corporate network, HO, Vivo 1, Vivo 2, Vivo 3. So between this head office and branch 1, what type of technology do you recommend? Laser line or broadband?
Laser line.
I have connected one laser line from head office to branch 1 via serial port. Serial port number 0 S0. Then head office branch 1 can communicate. The next thing is we need to connect to branch 2 also. So I'm taking one more laser line connecting to branch 2 from head office. It's serial port 1. I'm connecting to branch 3 also one more laser line. So total how many laser lines are used here? 3 laser lines. One laser line for head office to branch 1, branch 2 and branch 3. So this type of topologies we call star topology. Star topology, or we can call the hub and spoke topology. Hub and spoke. So multiple branches are connected to one centralized branch called star topology or hub and spoke topology. See a branch 1 connect to head office, branch 2 connect to head office, branch 3 connect to head office. So the good thing in star topology is less number of connections. How many laser lines? Only 3 laser lines we use. So less number of connections means implementation is simple. Deployment is very easy actually. Maintenance, no maintenance issue. Maintenance also simple. Agree? Yeah. But how exactly branch 1 and branch 2 can talk each other? How branch office 1 LAN uses traffic will come to branch 2. Do you have any direct link from branch 1 to branch 2? No. Like all spokes can communicate each other via hub, via head office. So branch 1 traffic will come to head office to branch 1. So branch 1 traffic will come to head office to branch 3. So all spokes can talk each other using via hub only, which is head office, central office. Like what if link between head office and branch 1 is failed? Link between branch 1 head office failed, then branch 1 head office can communicate? No. Branch 1, branch 2 can communicate? No. Branch 1 and branch 3 can communicate? No. Right? Muhammad is asking one question, sir. We are using a broadband at home. Do anyone monitor? It means there is chances actually. It's not like simply monitoring. They need some high-end tools. High-end tools. See, why they need to monitor the traffic? Are you any commercial network? Are you generating any commercial network? No. It's general browsing access only, right? So if someone is monitoring your traffic, they need very high-end applications. They need to be purchased actually. Why will they will take a risk? They don't take a risk actually. Anyhow, if they capture also no problem because you're secured. Nowadays you're using almost all applications are high secured. HTTPS, your traffic is encrypted, no problem. Okay. Right. So come to WAN topologies. Like if link is down, then no communication. We call it is single point of failure. One link is failed, no communication, no backup, no redundancy. Agree? So there is a drawback in star topology. No redundancy, no backup. But good thing is what? Less number of connection. Easy to deployment. Like simple. No maintenance issues. Very easy to deploy. Less number of connections. But drawback is what? No redundancy, no backup. So for backup purpose, what I'm doing is I'm using one more lazy line from branch 1 to branch 2. One more lazy line from branch 2 to branch 3. One more lazy line from branch 1 to branch 3. Like each branch connected to each other. So this type of topology is we called full mesh topology. So multiple lazy lines. Now link between head office and branch 1 is failed. Now branch 1 head office can communicate? Yes or no?
Yes, actually, with other lease line.
Yes. How branch 1 traffic will come to branch 2? Branch 2 head office can communicate now. Okay. Like branch 1 to branch 2 also link is failed. There are two links failed. Direct link and branch 1 to branch 2 also failed. Now branch 1 head office can communicate?
Yes, it will take from the branch 3.
Yes. So traffic will come to branch 3 to head office. So means here even multiple links failure also communication. Even multiple links, two links fail also, they can communicate actually, right? So this is a good thing in full mesh topology. So which topology do you recommend to use? Star topology or full mesh topology?
Full mesh.
Full mesh.
Full mesh. So for full mesh topology, how many laser lines are required?
6.
6 laser line. Each laser line we need to pay. What is the bill price for each laser line for monthly?
Hues.
And top of that, for each branch, 3 laser lines need to be maintained. Head office 3 laser lines, S0, S1, S2. Branch 1 3 laser lines. Branch 2 3 laser lines. Branch 1, branch 2, branch 3. More number of links. It creating a complex. Deployment issues, maintenance issues will come. And high expensive also. You're just seeing one side of the coin actually. Other side of the coin is also 100 shikna, right? But in case of star topology, less number of connections, easy to implementation, no maintenance issues. Simple. Only thing is no redundancy, no backup. Now tell me, which one you recommend? Star topology or full mesh topology?
Mesh only.
Full mesh. Oh, why full mesh?
Backup, sir. We
Backup you need. Okay. Do you need a backup or do you need a multiple backups? I repeat my question. Do you need a backup link or do you need a multiple backup links?
Backup link.
Backup is good enough, right? Because already you are using what type of connections is not a broadband connections, is a laser line connections. Laser line, there is a promise action. There is agreement. What is the agreement? Less than 1% downtime. Almost we don't downtime action, right? Only there are chances for downtime. How much percent? 1%, less than 1%. So for less than 1%, then why we need to maintain the multiple backup links? Agree?
Yes.
Yeah.
Can we
So
do a partial
it's-
mesh?
Yeah, exactly. There is one another topology. It's a combination of both star topology, full mesh topology. Call it is partial mesh. Partial with one backup link actually. A mix of star topology and full mesh topology, partial mesh. So these all are different type of WAN topologies are available based upon organization or network architecture will be designed your topology actually. Based on that, they will use or full mesh or partial mesh. It depends to organization to organization. These all topologies are available actually. Okay. Star or hub and spoke topology, easy to deploy, less number of connections. Thing is, no backup, no redundancy. Full mesh topology, all branches interconnected with full redundancy. More connections, complex configuration. Partial mesh topology, mix of star and full mesh topology.
There's no big difference. I think just only one extra.
At least, yeah. If you one more link also, it's a problem, right?
Yeah.
Next, point number 3. WAN connectivity. Like how these laser lines are connected, what type of equipment they use, what type of cables they use. Is WAN connectivity. So to connect to sites, we must require two type of connectivities. One is physical connectivity. And one more is logical connection also. Physical connectivity means cables, devices, something we required. Logical connection means IP address, protocols, like. So these both are mandatory, physical and logical both, between these two sites. First, let me explain about physical connection. Cables we need. Can we make a direct cable from your Chennai office to Bangalore office? Like one office in India, one office in UK. Like, can we make direct cable?
No, not
No.
possible.
Not possible. But there are some companies, they have already cabling part. The company purpose is they need to maintain a cabling. Actually, they will provide a cabling for connecting state to state, country to countries, all over India wide or worldwide. So they have a cabling part actually. So we can take a line for 1 year, 2 years, 6 months, taking a line for lease or lease a line. So contact your local service providers who will provide a lease line connectivity connecting to your Bangalore office. Then that service providers will maintain some devices to provide a lease line connection. The devices are MUX. Same setup in other end also. Multiplexer. From MUX they will provide a cable. That cable is RJ11 copper wire, like single pair of copper wire. Where we going to connect this cable? We going to connect it to LAN port or WAN port?
WAN port.
What type of WAN ports do you have?
But
Normal serial and smart serial. Normal serial is how many pins? 60 pin. Smart serial is 26 pin. But from MUX, what type of port is coming? RJ11. Can we connect RJ11 to serial port? 60 pin or 26 pin? No. So we need one converter. Says CSU DSU modem.
I think I missed it. What is the MUX?
Multiplexer.
Okay.
CSU DSU modem. Modem to MUX. Like this modem will convert like RJ11 signals to 60 pin signals or 26 pins. And MUX job is it also is to convert the signals like analog signals, digital signals will convert actually. This is one a traditional laser line connectivity, not a modern. It's a traditional laser line, but modern we'll get directly optical fiber cable without any modems. Is it? Same in other end also. MUX to modem. Because this traditional laser line connectivity is there in Cisco syllabus, that's all. Okay. CSU DSU. Channel service unit, data service unit. MUX to modem. And MUX to MUX, they'll maintain optical fiber cable. Okay. OFC, optical fiber cable. Yeah, this is WAN connectivity, laser line connection.
So the modems are placed in our office, like the company's site, or
You can see the shadow from building.
okay, got it, got it. It's in the company's.
Yes, the companies.
Okay,
Like we call it is CPE,
okay.
customer premises equipment. Yeah. The next thing is point number 4 about DCE, DTE. Devices. This is your home network. And this is your Wi-Fi router. Mostly you'll have a D-Link, right? Yeah. So your devices are connected to Wi-Fi or wired, whatever it is connected.
దీన్ని చాలా 40 మీటర్
From ISP, you got a link.
ఆటలు అయిపోతుంది మధ్య మధ్య.
నెట్ సరిగ్గా లేదు.
So what type of cable it is from ISP to your customer? RJ45, Cat6 or Cat5e, right? That is, it's a Cat6 cable. So what is the bandwidth for Cat6 cable?
10 Mbps.
Cat6 DTR transmission, that is what?
1000 MB.
1000 Mbps. Okay. It means as a customer, you are reaching internet with 1000 Mbps?
రెండో
Is it?
Wait.
What is saying? So you have your link keys can support up to 1000 Mbps now. It means as a customer, you are reaching internet with 1000 Mbps? No.
No.
Then who will configure bandwidth? See, there are two ends. One is a customer router WAN port and ISP router WAN port. Two ends are connected, right? Cable. Yeah. Then who will configure bandwidth? Who will set the bandwidth for this link? ISP will set that bandwidth, right? As per the customer plan, or it is a 40 Mbps plan or 80 Mbps plan, whatever, based upon your plan, ISP will configure. ISP will configure so and so on WAN port bandwidth is 40 Mbps. Now it will update to customer WAN port. Where customer WAN port, so have set the speed is 40 Mbps. Now it will make it is a 40 Mbps. Now link speed is what?
40 Mbps.
40 Mbps. Then your data will flow through 10 Mbps or 20 Mbps or 40 Mbps, whatever. Now your link is max is 40 Mbps actually. So here, the device which generate the bandwidth, the device we call master, the device which will accept it is a slave, master and slave. So technically, master is nothing but DCE device, data communication equipment, and slave is DTE, data termination equipment. So currently your plan is 40 Mbps. After 6 months, you want to upgrade your plan to 80 Mbps. As a customer, can we configure on your WAN port 80 Mbps? Can we set it?
No, only ISP can do.
No, we cannot do. If you're able to do means why then why we need to wait for 6 months? Initially I can do it, right? Yeah. So we need to update or need to mail to service provider, I want to upgrade my plan to 80 Mbps, then ISP will change, will configure to 80 Mbps. The link will what? 80 Mbps. So the device which generating the bandwidth, the device what we call?
Yes.
Data communication equipment. Is it
DCE, data
DCE or
communication.
okay.
DCE, not DEC, sorry. It's DCE, data communication equipment. Okay. Yeah. It's a device classification. DCE and DTE. Data communication equipment, generating clocking. Clocking is nothing but speed is a master. Data termination equipment, accepting clocking, nothing but a speed is a slave. Customer router. It's clear? DCE, DTE. No more doubts here? Okay. Point number 5. Serial cable.
So I have a small question here.
Yeah.
So if suppose if I wanted to upgrade to like 180 Mbps from 40, so they'll do it from the like ISP site or they like how it will work
On
actually
port,
exactly?
from where you are getting your cable,
Hmm.
see this is your internet cable, right?
Yeah.
Connect to your Wi-Fi router.
Yes.
You're getting cable means there should be one other end, right?
Is the other end will be like in my
Other
area, right?
end
It will
port.
not be in the ISP office.
It is, yeah, it is the area,
It's like
but
a switch.
ultimately it will go to ISP side only.
Okay. Okay.
So what ISP will do for this port only from remotely, they log into your area route device and which port
Okay.
your customer connected, and that port they'll set a speed actually.
Okay. Perfect. Perfect. Yeah. Now it's clear.
So for your area, commonly they'll get optical fiber cable very fast. From this device, they can distribute.
Yeah.
You are a customer, your customer is 80 Mbps, another customer may be 40 Mbps, another customer may be 60 Mbps. So they will set a speed on that ports actually.
Okay. Got it. Got it.
So
Because
between two sites, yeah, please.
because I used to work with a like a giant telecommunication company here, like Rogers. So I used to do it to my customers, but I don't know like exactly what happens in the back end. So when the customer asks like I want to upgrade to 1 GB, so automatically I just click a button in my system and automatically they'll get 1 GB data. So now I came to know like how it will work from the back end.
Yeah, correct. So from as an engineer, you are just clicking on 1 GB data, right? So that
Yes.
program is done, is already programmed. From your end, if you do, but we'll switch over to the port of the customer actually.
No, no, actually, we have a technical department in the back end, so they used to take care of these kind of things. I'll just send an instruction to them.
Okay, okay, okay.
Yeah, yeah, and thank you.
Yeah. So now point is again, like what type of equipment, what type of cables are used between the two sites for lease line, your branch 1 to branch 2 to connect it, what type of equipment, what type of devices we used actually. There is no possible to make a direct cable from one side on the other side, right? Then we need a modem, mux, optical fiber cable, copper wire, correct? These all the devices are required. But what if the distance between two routers is short? Your router 1, router 2, both are in your within a rack only. In one rack, now one router, another router, you want to connect it back to back. Then, so when distance between two routers is short, now we don't require optical fiber cable. We don't need a modem and mux and copper wire. These all are replaced with one special cable called serial cable, which is V35 back-to-back cable. So this cable we can use only the cases is when distance between two routers is short. A special V35 back-to-back cable is used to replace copper wire, modem and mux. This is a cable actually, serial back-to-back cable. For data communication, using back-to-back serial cable, one end has to be DCE, other end has to be TTE. Like I have connected a cable from branch 1 to branch 2 using a serial cable. Now in this case, which one is a master, which one is a slave?
Branch 1 is the master and branch 2 is the slave.
Why branch 1 is master?
Because branch 1 is the main source for having a data which contains.
How we can say branch 1 is the main source? So branch 1 means is the main, like this?
No, not like that. Normally, every data will be connected with the first position, and due to seeing of IP address also, we can say about it. It's a primary one.
No, it's not like that.
Okay.
Yeah. This cable, let's say example, this cable is Maxon can support 12 Mbps. Consider this cable Maxon can support how much speed?
Yes.
12 Mbps because it's serial cable, right? Okay. But now we want to set this cable as 2 Mbps or 3 Mbps. Otherwise, it allows us to 12 Mbps default. But our requirement is we want to make this link is 2 Mbps or 3 Mbps only. We have it two ends. Branch 1 serial 00 and branch office to serial 01 and two ends, right? Any one end we have to set that speed. Another end will accept it. So that is predefined. A cable is predefined. See, one end is already predefined. It is what? DCE. Other end is what? DTE. So where you connected is matters actually. You connected DC end. Here it is a DCE. Another end should be is what? DTE. Then you want to make this cable is 2 Mbps. Where we need to configure it? Where we need to set it?
DC.
DC.
DCE. So log into branch 1 router and give the command interface serial 0/0 bandwidth. Sorry, clock rate. Clock rate is 2 Mbps because the master. So in branch 1 only we can change the speed. Clock rate we can set actually. Or we can connect other end also. So you have connected DC in here, DTE here. It's up to you. Now where we need to set the speed?
DC.
Branch
S01.
2 S01.
Yeah.
So it depends upon your how you are connected the cable actually. So this cable is this.
So this
Clearly
cable
make
is connected between like two branches or
No. This cable
two
only
routers?
for two routers.
Is there any like a distance?
Uh,
It should be like within
5
2
meters,
meters.
10 meters only.
Okay,
Maximum.
okay.
Yeah.
Because when you said like branches, I thought it's like kilometers of
No.
distance between those two, but the cable is
If it
too
is a
short.
branches, then ultimately this equipment is required.
Okay,
Modem,
perfect.
optical fiber cable like this.
Okay, got it.
So this is only for when distance between two routers is short, like a meters, 5 to 10 meters. It's clear?
Yes.
Okay. Point number 5 is done. And point number 6.
Sir, actually one question.
Yeah, please.
If two router in same location and connected with DC DT cables, and we want to configure the bandwidth at DC and remotely, then how to know that DC connected at which router?
We can use some commands to know which port is DC and which port is DTE. Log into branch 1 and check the status of your serial 0/0. Show interface serial 0/0. Then it will give output whether it is a DC or DTE.
Okay.
If it's DTE means other end should be DCE.
Yes.
Or if
Yes.
it's a DC means other end should be DTE.
Okay. Actually, I want to know the command.
Yeah, I'll give that command. Yeah, no problem. Okay.
Yes.
So fine. Finally, yeah, branch 1, branch 2. If both routers are in same, shortest distance, you can use V35 cable. Or one is in Chennai, one is in Bangalore, and you can use a laser line connectivity. However, they're connected actually. That is what physical connection. A logical connection is fundamental rule. The rule is point to point, back to back connected. A branch 1 serial port 0/0. Other end it is connected to where? Branch 2 serial 0/1. So these both interfaces always must be in same network address. Like example here, if I assign 170.16.0.1, other end should be same network. So here it should be 172.16.0.2. Yeah. So this is fundamental rule actually. Both ends should be in same network address. Okay. Do you know how to assign IP address? Already have given commands yesterday for LAN port. Interface fast Ethernet 0/0, enter IP space, address space, subnet mask. And what is the command to activate the port? No shutdown. Correct? Yeah. Similarly, same interface serial 0/0, IP address, subnet mask, no shutdown like this. Okay. Your data traffic is generated from one of the device. A data packet is generated. We'll come to fast Ethernet port. Fast Ethernet port. What fast Ethernet port will do? See, this traffic will come to which port of the router? Fast Ethernet. What fast Ethernet port will do? Fast Ethernet will send to branch to router? No.
Yes.
How? Fast Ethernet port is not connected to there, right?
Yeah, router to device.
So what fast Ethernet port will do? It will send traffic to which port? Serial port. What we call this process?
Data forward.
Packet forwarding.
Switching.
Okay.
Switching.
So packet switching means sending a IP traffic from one interface to another interface, right? Yeah. So all users traffic will come to fast Ethernet port. Fast Ethernet port will send traffic to serial port. We call it as packet switching. Now what serial port will do? What are the data traffic? Will come to LAN port, it packet forwarding. Yes. The thing is, before forwarding data packet, your serial port will do one thing actually here. It will add headers. For every data traffic, serial ports will add what? Headers. And then traffic is being forwarded actually. For every data packet, serial ports will add headers information, and data plus headers both are being forwarded. Anyone remember what we call the process adding a headers to data?
Segment.
No.
Packet.
No, what we call this process adding headers to data packet.
Encapsulation.
Excellent.
Oh.
Encapsulation. So here we are discussing about point number 6 is WAN interface, WAN encapsulation. Okay. Basically, WAN encapsulation is two protocols we have. WAN encapsulation protocols are two types of protocols. One is PPP, point-to-point protocol. Point-to-point protocol. Another one is HDLC, high-level data link control. There are two protocols. Your R1 router, R2 router, both are connected, right? So R1, R2, both routers are Cisco routers, Cisco vendor, both are Cisco routers. Then every Cisco router by default encapsulation is enabled, which is HDLC. So HDLC protocol is Cisco proprietary protocol. It works in only Cisco devices actually. Even we need to be configure HDLC. Is already enabled in all WAN ports. By default is enabled in WAN ports. Whenever traffic will come to Cisco router WAN port, it will add what type of headers? PPP headers or HDLC headers? Cisco routers. Cisco routers will add HDLC headers because HDLC is enabled in already in all Cisco WAN interfaces. Because HDLC works in only in Cisco vendor actually. So data plus HDLC headers is been added and move to next router. If next route is also is what Cisco router, then which protocol works here? Which protocol is enabled on serial port? HDLC.
HDLC.
So it is traffic is coming from HDLC and other end also HDLC, then your link will come up actually. Like what in case in your branch side, your branch site 1, you are using Cisco router. In branch 2, you are using non-Cisco device like a D-Link or HP, MyPu, Juniper, any other vendor. Call this non-Cisco. Then in non-Cisco devices, HDLC works? No, HDLC not works because HDLC is a Cisco proprietary protocol. So there is one another protocol which is Open Standard Protocol. Whenever I say open standard means, you understand, open standard means it works in multiple vendors. Okay. Multiple vendors means point-to-point protocol works in Cisco routers. Point-to-point protocol works in non-Cisco device also. So we can configure PPP in Cisco routers and it can work in non-Cisco. It's an open standard protocol. The good thing is point-to-point protocol can support for authentication. to preventing from the false routing information, like every routing protocols can support for authentication. So point-to-point protocol can support for authentication, but SDLC, no authentication. It won't support for authentication mechanism. And point-to-point protocol can support for compression mechanism. SDLC, no compression. Okay. So there's a major difference between point-to-point protocol and SDLC. Triple P and SDLC. It's clear? But what is important point you need to remember here is in one end is SDLC. In other end also it should be SDLC only. Always your encapsulation should be match. So one end header is triple P frame, triple P header. In other end also triple P header. Then only your link will be up. In one end is point-to-point protocol, other end is a SDLC. No, your link will not come up. It will be down actually. Remember yesterday when you give a no shutdown command, you got 2 log messages, 2 times up message. Yes. One for what? Interface is up. One more for what? Protocol is up. But whenever protocol is mismatch, you don't get protocol is up. Protocol will be down only. So these things you need to understand. One end if you configure, if it is a Cisco vendor, other end is a Cisco vendor, both sides you can configure SDLC or no need to be configure anything because SDLC is enabled. Or you want to support for authentication, you can configure both ends is point-to-point. Because point-to-point is open standard, it can work in Cisco also and non-Cisco also. Or one end is a Cisco, other end is a non-Cisco device. Then we can't go with the SDLC now, only drop point-to-point. So configure point-to-point, other end is point-to-point protocol. If NCAPS is mismatch, for example, one end you configure point-to-point protocol, other end is a SDLC. Now what happen is, now when SDLC traffic is coming to point-to-point protocol will say, oh, you are non-authenticated protocol, I can't trust you because your traffic, it may come with a false information. You're not authenticated. I will not accept your traffic, I'll drop it. If it is a point-to-point protocol traffic, yes, I can trust your traffic because you are authenticated protocol, you support for authentication, I also support for authentication. So let us communicate. At both ends is a SDLC. There is no matter of authentication. There also communication is possible actually. So make sure always point-to-point, one end, other end, protocol encapsulation should be matched. If it is a mismatch, your protocol will be down. Link will not come up actually. Get it? Yeah. And there's a difference between encapsulation. And configuration part is this. Yeah, this is a command to get to know DC and DTE. You can use this command, show controller serial and port number. This command will give you about which interface is DC, which one is a DTE. All show commands need to be executed in privileged mode. And this is the WAN interface configuration. Interface serial number, IP address, no shutdown. If it is a DCE, then you can generate a clock rate. If it is a DD, you can ignore it. And you want to configure encapsulation, you can use this command. So this clock rate command is only for DC interface. If your port, if interface is DTE, you can ignore it actually. Okay. Any doubts? Just a minute, I'll show you the practical. So first step is diagram. Right? So we'll implement, we'll do practice on 3 routers. This is the topology. Number of routers. How many number of routers? Three routers. I'll do one thing. I'll take the first router as 2611. It is 2811. And it is also 2611 model. Two 621 we have. Okay, using 2621. We're also 2621. 1, 2. Middle I'm using 2811. So what type of cable we need to use between router to router?
Same device, so crossover cable.
No, we are not connecting to LAN port, right? We are connecting to serial port to serial port. So we have to use serial cable. Yeah. You can see the connection. There is one serial DCE cable, clock symbol showing, right? I can use this clock symbol cable. If you click on first router, what ports are available?
So auxiliary console, fast
Console,
Ethernet.
fast Ethernet 00, fast Ethernet 01, but it's not showing the serial ports, right? So by default, there is no serial ports and routers. We need to add modules. Okay, I'll show you how to add it. You just click on router, and if you see here, slots are empty. WAN slot 0, WAN slot 1 are empty. So we need to add the modules. In the left side, you have different type of modules. In second last, WIC2T, WAN interface for 2 terminals. You can use this. So just in the right side, bottom right side, you can see this slot. You can drag it and drop here. But before drag and drop, your router power should be off. Off, drag it and drop here, and power on. CLI, now it is booting up. Similarly, see it is 2811 router. We can see more slots are available. Same like power off, WIC2T, drag it and drop here. This is 2800 series. For 2600 series, you can get only few slots actually. See, only 2 slots are available. WIC2T, drag it and drop here. Yeah, but before drag and drop, your power should be off. Cannot add a module when the power is on. So power off, drag it and drop here. Now can use the cable, serial DC cable, click on router 1. So serial ports are available now. So port number 00. You can use one also, any one. For example, 00. In other end, here you can see 3 zeros, serial 0/0/0, 0/0/1 because it is 2811. So I'm connecting on to serial 001. Again, 0002, just 01. So if you're confused on which port number you got connected, you can go to options, preferences. No, you just click on always show port labels. Then serial 0/0, serial 001, 00001. Like this. Okay. So click on first router. A best practice always you configured host name. This is your branch office 1. Host name is branch 1. In branch 1, interface serial port 0/0, IP space address as per example 170.16.0.1, 255.255.0.0, and no shutdown. So actually, if you give no shutdown, it should come up, right? But showing the down. Why? Other end still it is shut down. Only in one end we configure. If other end is also no shutdown, then it'll come to up. Okay. If it's a DCE, then clock rate, clock space, rate space. You can use a question mark. So it shows a list of bandwidth, how much can minimum and maximum can support. So can choose the clock rate from list above. I'm choosing 64,000 bits per second. And we want to enable encapsulation. Encapsulation. Triple P. For SDLC, no need to configure. Already is SDLC is there actually. For triple P, you need to configure like this. So I repeat the configurations. Interface serial 00, IP address, no shutdown, encapsulation, clock rate, exit. A clock rate command only for DC interface. If it's a DT, then no need actually. How to check DC, DT? Show controllers serial 0/0. What is showing here? It is DCE V35 cable. Clock rate we set 64,000. Yeah. Similarly, in next router, what is the best practice always? Set the host name. The head office. For head office, serial 0/0/1. IP address 172.16.0.2. 255.255.0.0. No shutdown. Now we got interface serial 0/2/1 change state to up. Clock rate is not required because DTE other end is already be configured now. Now encapsulation triple P. So now protocol is also up. When the protocol is mashing both end, then line protocol is also up. We got two types always up message actually 2 times. It's done. Now if you check status of branch 1 interfaces, you can use this command show IP interface brief. Show IP interface brief command and enter serial 0/0 IP assigned, status is up, protocol is also up. So you can check communication ping 172.16.0.2. You'll get success rate is 100%. So successfully WAN link 1 is active. WAN link 1 is configured and active. Similarly WAN link 2 also. Head office S000. The thing is one end we have assigned IP address is what 172.16.0.1. Here 172.16.0.2. Don't go with the 172.16. It should be different network. 172.17.0.1. Other end should be same. 172.17.0.2. Like this. Only back to back should be same. Here should be same. Okay. WAN interface configuration and verification commands. Yeah, done. So you please practice on 3 routers. Means 2 WAN links. This is the diagram. Any doubts? All right. So it's all about for today. And tomorrow we'll continue with WhatsApp group link. Huh? Think. Yeah. All right. So it's all about for today. Almost 7 points we discussed about WAN interfaces, WAN encapsulation, WAN configuration, WAN verification, 8 points. So tomorrow we'll continue with how to enable communication from LAN to LAN users. Branch 1 LAN users, branch 2 LAN users. Today only WAN interfaces we discussed. But ultimate target is what? Branch to branch communication. We need to implement routing protocols. So routing will begin from tomorrow. Thank you. Have a nice day.
Thank you.
Answer.